continue the section, let us discuss the next problem. Draw the transfer function of a system from the data given in the Bordeaux diagram. So this is a Bordeaux plot diagram which are given in the problem. So first let us have to find the value of omega 1, omega 2, omega 3. So between omega 1 and omega, that is 4 radians. So this is the value of frequency, 4 radian per second, and decreases by 36 dB per decade. So slope magnitude at omega 1, it is a 36. So magnitude 36 is equal to, so this slope from this point to this point, slope is 40 dB into corner frequencies. So first corner frequency is log of 4 and log of omega 1. So therefore we will get omega 1. So then calculate the value of k. So 20 log k is equal to 36 dB plus 20 log 5. So 36 dB is the positive slope. So we will get the value of k is 31.62. Similarly, to calculate omega 2, consider this point. This is the omega 2 crossover point. So magnitude is minus 12. That is, slope is same. Slope magnitude is minus 40 only. So then we have to use log of omega 2 minus log 4. So therefore omega 2 will get 8 radian per second. To calculate omega 3, so look at the graph. Omega 3 is point this. Magnitude is minus 21. So minus 21 plus 12. Because between this magnitude at this point there are the two slope changes, minus 22 minus 40. So then hence you have to consider this value. Minus 21 minus of minus 12 means plus 12. That equal to slope magnitude is minus 20 into log of omega 3 minus log 8. So from this we will get omega 3 is this much. Then first line of slope is minus 20 dB per decade, indicate the term 1 by s. So from the graph, this is the slope, minus 20 dB means 1 polar origin. So 1 polar origin means the slope is 1 by s value. Not passing through omega equal to 1 radian per second, the term is k by s. K is known, 31.6 divided by s. Then at omega 1 equal to 0.5 radian. 0.5 radian already you have to calculate it. The slope changes from, if you consider this is the point, the slope changes from minus 20 to minus 40. So minus 22 minus 40, which indicate the term in the denominator. So denominator term, that is 1 over 1 plus s by omega 1. Omega 1 is known, that is 0.5. So we will substitute the values. Next is to find the value of omega 2. So omega 2 is 8 radian per second. The slope is changes from at omega 2. At omega 2, if you observe the graph, at omega 2 the slope changes from minus 40 to minus 20. So that is decreasing of slope. The slope changes from minus 40 to minus 20, which indicate the term in numerator. So the term is present, the factor is present in the numerator. So we get this value, that at omega 3 equal to 22.5. So at this omega 3, as we know that already we have to calculate it, that is 22.5. So the slope changes from minus 40 dB. So observe the graph. This is the graph. The slope changes from minus 20 to minus 40. So the factor which is present in the denominator. So denominator. So then we will get this values. Similar type. Next, third problem. So data is given, clear, there is no difficulties. So the first line has the slope minus 20 dB per decade at omega equal to 1. It's not passing through, omega is equal to 1 radian. So therefore 20 log k is equal to magnitude is minus 9. So k is, we will get 0.35. Then at omega is equal to 1, the slope is changes from minus 20 to 0. So which indicate the term numerator, which present the factor in numerator. Therefore it is 1 plus s, because omega is 1 radian per second. At omega is equal to 20. At omega is equal to 20 means you can observe this. Observe the graph. At omega is equal to 20. Slope is changes from 0 dB to minus 20 dB per decade. Okay. So then the factor is present in, plus 20 dB per decade. The factor is present in numerator. So we will get the values. Then last corner frequency at omega is equal to 40. The slope is changes from plus 20 to 0 dB per decade. Yes, 0 dB per decade. Indicate the term in denominator. So we'll get, finally we will get the all the factors, that is complete transfer functions.